In this video, I'm gonna go over some basics of differential equations, like finding the order, degree of a differential equation, and to see if either it's a linear differential equation or a non-linear differential equation. So let's go over some examples. So first of all, let me write down a differential equation over here. So let's say I got dy over dx square plus 2x plus 4 is equal to 0. So first of all, we're going to talk about order of a differential equation. So by definition, the order of a differential equation is the order of the highest differential coefficient, or basically in simple way, if it's a first derivative, order is 1. If it's a second derivative, order is 2. So let me write down second example to write down the order. So d square y over dx square plus, let's say, x dy over dx plus 6 is equal to 0. In this case, the order of this differential equation basically is the order of the highest differential coefficient, or for example, this is a second derivative. You see, d square y over dx square, so the order is 2. If it's a third derivative, order is 3. Now let's move over to degree of a differential equation. So if I write down equation here, d square y over dx square plus 7 dy over dx plus 2 is equal to 0. So the degree of differential equation in simple way is basically the power of its highest derivative. In this equation, in this differential equation, which one is the highest derivative? This term or this term? This is a first derivative, this is a second derivative, so this is our highest derivative. And what is the power of this highest derivative? So let's say if I put parentheses over here and put 1 as a power, that tells me the power of the highest derivative in this differential equation is 1. So the degree of this differential equation is 1. How about the order? This is a second derivative, the highest, then the order is 2. Let me write down another example, that way you will see the difference. So if I have let's say d square over d square y over dx square raised to power 3 plus 6 dy over dx plus 4 is equal to 0. How about now? What is the order? First of all, it's a second derivative, see, d square y over dx square, so the order is 2. How about the degree? Degree is the power of the highest derivative. So the highest derivative is second derivative, this term over here, and the power of this term is 3. So the degree of this differential equation is 3. Okay, so order is basically what derivative it is. First order, first derivative order 1, second derivative order 2, and degree is the power of the highest derivative. Like in this example, it's 1, so degree is 1, and the power of the highest derivative in this term is 3, it's 3. Now I'm gonna go over linear and non-linear differential equations. So by definition, a differential equation is said to be linear if the unknown function, let's say we got a function y and this is unknown, we don't know, and if this unknown function and all of its derivatives are in first degree and are not multiplied together. Again, a differential equation is said to be linear if the unknown function and all of its derivatives are in first degree and are not multiplied together. So let me write down. So this is a function. So derivative of this function, let's say dy over dx with respect to x is equal to 5. So look at this. What is the power of this derivative? 1. So degree is 1 and the function or its derivatives are not multiplied together anywhere. So this is a linear differential equation. Let me write down another example. So d square y over dx square plus y is equal to 0. Again, what is the degree of this differential equation? The power of the highest derivative here is 1 and the function or its derivatives are not multiplying anywhere. So this is again a linear differential equation. So let me write down a non-linear differential equation. For example, if I have, let's say d square y over dx square raised to power 2 plus x square dy over dx cube is equal to 0. What is the degree of this differential equation? The power of the highest derivative, which is 2. And dy over dx is multiplying 3 times, that's why there is a cube. So the derivative of the function is multiplying with its derivative here. So that means this is not a linear differential equation. This one is a non-linear differential equation. Again, the definition is a differential equation is said to be linear if the unknown function, let's say y, and its derivatives are in first degree and are not multiplied together. So this case, the derivative is in first degree, either function or its derivative is not multiplied anywhere, so linear. Second example, again degree is 1. I don't see either function multiplied by its derivative or its derivative multiplied by its derivative, so this is a linear again. In this example, degree is 2. It's not first degree, it's a second degree differential equation. And here function dy over dx is multiplying with its derivative dy over dx, and one more time dy over dx. You see that? That's why there's a cube. So that's why this differential equation is a non-linear differential equation. Okay, so let me write down one more example and then we will be done. So for example, if I got x dy over dx plus 3 divided by dy over dx is equal to y square. So they said find the order, degree, and tell if it's a linear or a non-linear differential equation. So first of all, I will try to simplify it. I want to get rid of this denominator, which is dy over dx. So what we can do, we can multiply both sides by dy over dx. dy over dx. So this will give me x into dy over dx square plus dy over dx is in the numerator and this is in denominator, will cancel out, left with the 3 and we're left with the y square dy over dx. Now subtract y square dy over dx from both hand sides. We got x into dy over dx square minus y square dy over dx plus 3 equal to 0. So first of all, what is the order of this differential equation? Look at the highest derivative, it's first derivative. See, dy over dx. So order is 1. How about the degree? The power of the highest derivative. So dy first derivative is the highest derivative and its power is 2 here. So degree is 2. And now we need to tell if it's linear or a non-linear. So linear equation, degree need to be 1. So first condition didn't meet our condition for linear differential equation. So that means this is basically a non-linear differential equation. See? So degree is not 1 and the function is multiplying with itself and it's multiplying with the derivative of the function. That's why it's non-linear. Okay, if the degree was 1 and the function or its derivative were not multiplied together, then it was a linear differential equation. All right, I hope this will explain you the difference between linear and non-linear differential equation and how to find the order or the degree of a differential equation. I'll make another video with more examples. Thank you for watching the video, guys. Please do share with your friends and please do subscribe to the channel. I really appreciate your help. Thank you. Have a good day. Bye-bye.